azeotropic mixture, minimum boiling azeotrope, maximum boiling azeotrope, ideal solution, non-ideal solution, and what are the graphs and what are the important conditions for the ideal and in the case of non-ideal. And in the non-ideal also we have the two different types, positive deviation and the negative deviation. So any doubts in these? Any doubts in this?
No, sir.
If you have any doubts, you can ask me or else we'll start the new topic, today's class. And today's class, we have some numericals also. Can you start the class?
Yes, sir.
The next one is the colligative properties. So colligative properties is a property which depends only upon the number of solute particles and does not depends upon the nature of the solute particles. So it is a property which depends only upon the number of solute particles and does not depend upon nature of solute particles. That means what? Whatever the particle it is, it can be ionic particle or the atom or the molecule. It does not depend upon anything. It will depend upon only on the how many particles are there. Either 10 are there, 20 are there, or 30 are there. Based upon that only, this property will be decided. That is only the colligative properties. So what are the factors which affect the colligative properties? First one, fraction of solute. And solvent particles in solution. That means the amount of solute particles and the amount of solvent particles in the given solution, that depends. Next one is the nature of solvent. If the solvent is less viscous now, the particles will move freely, right? Whatever the solute particles are there, it will move freely in the less viscous solvent. Or if the solvent is more viscous in nature, the particle will not move at all. The movement of the particle will be restricted. That is the second factor. The third one is the association and the dissociation. That is a third point. Okay, so these are the factors on which the colligative properties are depend. So total we have the 4 different colligative properties are there. The first one is a RLVP, relative lowering of vapor pressure. Okay, so it is a general having the formula of P naught minus P by P naught equal to mole fraction of solute. Okay, so generally we'll call it as a RLVP, relative lowering of vapor pressure. Second one, elevation in boiling point. That is delta TB is equal to TB minus TB naught, or we can write delta TB is equal to KBM. So where this KB is called as an biblioscopic constant, or molar elevation constant.
So are these the types of colligative properties?
Yeah, total we have the 4 different types of colligative properties.
Okay.
Okay, the first one is RLVP. That is a formula, and shortcut we'll call it as a RLVP. There is a relative lowering of vapor pressure. The next one is the elevation in boiling point. See, actually there is a lot of theory part is there for this derivation part and all, which is not important for the JEE point of view. That's what I'm not giving the derivation part and all. Just I'm explaining the formulas itself. Fine.
Yes, sir.
So in the regular NCERT class, we'll cover that derivation part. So in the third one, you have the depression in freezing point. So you have the depression in freezing point in the third point. That's a delta TF equal to KFM, or you can write delta TF equal to TF naught minus TF. Okay, here KF is a cryoscopic constant. Okay, and what is the M here? Molality. Already you know what is the formula for molality? What is the formula for molality? Anyone? What is the formula for molality?
Number of moles of solute by volume of solution in liters.
That is a molarity formula. Whatever you are telling is that is for the capital M molarity.
Mass of solvent in kg.
Okay, then can you tell me full formula like small m equal to?
Number of moles of solute by mass of solvent in kg.
Very good. Number of moles of solute by mass of solvent. That's a molality formula. So whatever the small m you are writing here, that is a molality only. Next one is the osmotic pressure, indicated with the pi is equal to CRT. That's the C is a concentration, pi is the osmotic pressure, C is the concentration. What is the concentration formula again? Number of moles of solute present in the volume of solution. So N by V, and R is the universal gas constant. And T is the temperature in Kelvin. Okay, that is a pi equal to CRT. So these are the 4 different colligative properties. The first one, what is the formula? RLAP, what is the formula? What is the P naught component here? Vapor pressure of pure solvent. Okay, P is the partial pressure of solution. P naught is the vapor pressure of pure solvent. P is the partial pressure of solution. Mole fraction formula, you know, mole fraction of the solute is equal to Na by Na plus Nb. Clear these formulas? Any doubts in these?
No, sir.
So these are the 4 different formulas. Now I will tell you with simple explanation part only all these 4. Suppose, because each and everything is not important in the derivation part and all, so only I'll tell you only with simple expression part. Already covered this. Suppose you have taken the two solutions or the two solvents. One is a only volatile solvent. In the next case, this is also a volatile solvent, but just we added the non-volatile solute. Here there is only the volatile solute is there. Volatile means what? Which can evaporate easily, right? And now we have covered with the something here in both the cases. Now tell me, in which case the vapor pressure will be more? First case or second case? In which case the vapor pressure will be more?
First case.
First case.
First case. Why? Because the solute is a volatile in nature and the solvent is also volatile in nature. So the particles will move easily from liquid state to gaseous state. If more number of particles are there in the gaseous state, there will be more vapor pressure, right?
Yes, sir.
Okay. In the second case, what is happening? Due to addition of non-volatile solute, the vapor pressure of the solution is decreasing, right? Yes or no?
Yes, sir.
Due to adding of
Yes, sir.
non-volatile solute, the vapor pressure of the solvent is decreasing. That means P naught will be higher or P will be higher. P naught is for the pure component. Whenever the naught is given, that is for the pure, without any non-volatile solute. Whenever nothing is given, that is a non-volatile, non-impure one. Now tell me which one is higher here, whether P naught or the P. P naught will be higher, right? The vapor pressure of the pure solvent is higher than the vapor pressure of solvent which contain non-volatile solute. Understanding?
Yes, sir.
Now, due to adding this non-volatile solute, the vapor pressure is decreasing or not? Yes, decreasing or not? Decreasing. So see here, lowering of vapor pressure due to the adding of non-volatile solute. How much it is lowering? P naught minus P is lowering. Okay, this much it is changing. With respect to what we are comparing? With respect to P naught we are comparing. So you can write as delta P by P naught equal to XS. That is the RLVP formula. The change in the vapor pressure with respect to the initial pressure when you are adding the non-volatile solute is a RLVP. Clear now? RLVP?
Yes, sir.
Okay, elevation in the boiling point. Now, if you give little temperature also, it will goes to the vapor phase and there will be more vapor pressure will be there on the surface of the liquid. What about this liquid? At the lower temperature, it will boil fast. Whether it will start boiling at the lower temperature, second one? No, right? We have to give more temperature. Then only the non-volatile solid particles will gain the energy and they'll go into the vapor phase. Then only it will start exerting the pressure on the solution. We'll take one common example. When you're boiling the eggs, some people will add the salt, right? Yes or no? When you are boiling the egg, generally we'll add some little amount of salt. Why? because to increase the boiling point of the water only, we'll add the salt. When you add the salt to the water will not reach the boiling point at the lower temperatures. It will take some more time to reach the boiling point. Understanding? Here also same. When you're adding the non-volatile solute, the solvent will not reach the boiling point easily. So we are increasing the boiling point of the solvent. That is only the elevation in the boiling point. So elevation in the boiling point is what? Compared to pure component, the boiling point of the solution will be higher. So TB will be higher. So we are subtracting from higher minus lower. Clear now? How we got delta TB equal to TB minus TB naught? Compulsory how to remember these two. Delta TB equal to TB minus TB naught, where TB is the boiling point of solution. TB naught is the boiling point of pure solvent. Can you see what I'm writing here on the right side?
Yes.
Here also what? TF. What's the TF naught? Freezing point of pure solvent. TF is the freezing point of solution. So in the case of TF, depression in the freezing point and lowering in the freezing point. First pure component will come, then solution will come in both the cases. So TF naught minus TF, delta TF equal to TF naught minus TF in the case of freezing point. Same relative lowering of vapor pressure also, P naught minus P, and delta TF equal to KFM. Okay, so KF value they will give in the exam, and molality we have to find out from the given data, and remaining things we have to find out delta TF and delta TB. Any doubts of first three formulas?
No, sir.
If you have any doubts, you can ask me. So fourth property is what? Osmotic pressure. See here, we know already reverse osmosis process for applying the desalination of water. That means purification of the water will apply the reverse osmosis process. First we'll study the osmosis. What is the osmosis? Spontaneous flow of solvent into the solution through a semi-permeable membrane. Okay. SPM. Suppose you have taken like this one beaker, and you have taken one solution into another jar. So if you have taken the solvent in the beaker, and now you have taken the solution in the this container. Okay, so this is the solution. This is the solvent, and whatever this thing you see here, right? This is the SPM, semi-permeable membrane. Now, the spontaneous flow, that means without any external factor, the movement of the solvent from the beaker into the solution through the semi-permeable membrane is called as an osmosis. Is it clear? That means the movement is happening from what? From the dilute solution to concentrated solution, right? The movement is happening from dilute solution to the concentrated solution. Or if you want to draw in another diagram, like this is a comfortable